The information presented is based on available literature and industry estimates. Actual impedance values may vary depending on specific factors such as building type, age, electrical system design, and maintenance practices. According to a study conducted by the University of Washington in 2015, the impedance from a distribution panel to an outlet follows a love-normal distribution with a mean of 0.49 ohms and a standard deviation of 0.21 ohms. This means that the majority of impedance measurements will fall within a range of approximately 0.28 ohms to 0.80 ohms. Based on industry experience, the typical range of impedance values for a distribution panel to outlet connection in residential and commercial buildings is as follows. Firstly, the minimum impedance is 0.15 ohms. Secondly, the average impedance is 0.45 ohms. Thirdly, the maximum impedance is 0.80 ohms. The impedance from a distribution panel to an outlet is affected by several factors, including wire size and length, where smaller wire sizes and longer wire runs result in higher impedance. Also affected is the number of outlets and appliances connected, where more outlets and appliances connected to the circuit increase the impedance. Building construction affects impedance, and impedance can vary depending on the construction materials used, such as wood, concrete, or metal. Electrical system design also has an effect on impedance, and proper grounding and bonding techniques can minimize impedance. Maintenance practices such as regular electrical maintenance, such as cleaning connections and tightening terminals, can reduce impedance. When designing electrical equipment for the US market, it is important to consider the expected impedance range from distribution panel to outlet. This will ensure that the equipment can operate efficiently and meet safety requirements. For example, power distribution units or PDU should be designed to handle impedance levels within the typical range. It is also important to note that the impedance may not be constant throughout the day. Factors such as temperature changes, load variations, and harmonics can affect the impedance. Therefore, it is advisable to design equipment with some margin for impedance variation.